This is the 3.3 Day 2 notes, and a lot of the stuff that we're covering in these notes, it's things that we've been talking about for the past 2 weeks or so, but it's rolling it in to the linear stuff that we just started. So you've heard me talk about the y-intercept and the x-intercept, and we've looked at a lot of graphs, and so now we're kind of just tying all that together and really trying to apply it to some word problems. So in your notes, it says the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. Okay, and we're going to use this graph to answer the questions. So the first thing that you want to do whenever you look at a graph is you want to see what type of information have they given us. So we already know that the graph is about this helicopter's first flight. Our independent variable, which is on our x-axis, is the number of hours that the flight has been going on. And then our dependent variable, which they've labeled as f of x, remember that's the same thing as y, is the number of miles that the helicopter is from its destination. Okay, so it's really important that you look at your x and your y-axis and you read those labels so that you can get an idea of what this line, what this data really means. Okay, so the first question here asks us what the y-intercept tells us about the situation. Well, the y-intercept is where the graph is crossing the y-axis. So I can see that that point occurs right here, and I know that the ordered pair for that point is 0 for the x-coordinate and 300 for the y-coordinate. Now, I want to think about what does that mean? Well, I know that x is the number of hours in the flight. So at 0 hours, well, that means I haven't started yet, right? I haven't taken off. I know that I am 300 miles from my destination because that's what this told me. It said that it shows the number of miles a helicopter is from its destination after X hours on its first flight. So this coordinate, which is my y-intercept, is telling me that I start 300 miles from my destination. So I know that the helicopter starts 300 miles from its destination by looking at my y-intercept. Okay, so usually, and we've talked about this over the last couple of weeks, generally speaking, your y-intercept is going to represent some sort of starting value. It could be how much you started with, it's how far you are, it's kind of the beginning of our scenario when you're talking about a real world situation. Okay? Alright, so then it moves on and it asks us to talk about the x-intercept. So our x-intercept is where the graph touches the x-axis. So my x-intercept on this graph occurs right there. And I'm going to go ahead and write that as an ordered pair. I know that that's at 3, 0. Okay? If you're on the y-axis, x was 0, y was 300. That's my y-intercept. Well, then the x-intercept, I went over 3, and then I didn't move up or down. So that one's 3, 0. Okay? So once again, I'm going back to my labels on my axes. So I know that it takes 3 hours, then I am 0 miles from my destination. Well, what does that mean? That means that it took them 3 hours to get to wherever they were going. Okay, so the x-intercept tells you that the flight took 3 hours. Okay, I know that if I'm 0 miles from where I'm going, I'm already there. Okay, so I know that it took me 3 hours to get there. Alright, so we have those two pieces of information. Now let's look at our next question. It says, how fast is the helicopter flying? Well, when you're measuring speed in this helicopter, we're talking about miles per hour, right? Because that's how you measure speed. It's your change in y divided by your change in x. That's your rate of change, or the rate at which the helicopter is flying. So you've heard me talk about that rate of change being change in y over change in x several times. Okay, so let's think about that. I know that I traveled, or the helicopter traveled, 300 miles in 3 hours. So I can find the average speed, or the average rate of change, by just dividing. So if I went 300 miles in 3 hours, if I divide 300 by 3, I find out that the helicopter is actually traveling at 100 miles per hour. And that would be how fast that it's flying. Okay? So this is 100 miles per hour. All right, let's look at this last question. So the last question asks, why does the graph slope down? So notice my y-intercept was up here on 300, and then the line is sloping down at a constant rate of 100 miles per hour until it hits the x-axis at 3. Well, why does that happen? Well, if you think about this scenario from the beginning, it tells you that the graph is showing the number of miles the helicopter is from its destination after X hours on its first flight. Well, if you start 300 miles away, every hour that you travel, you're moving closer to your destination. So the graph slopes down because you're moving closer to the destination the longer you're in flight. Okay? All right, so we covered all of this in class, but then there was a second part to this. So let's go ahead and look at that. So then it says we have a second flight. It says on its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. This time, instead of giving me a graph, because notice this graph was my first flight, see how it's titled first flight? They're going to give me an equation. They're telling me the function f of x equals 350 minus 125x represents that second flight. So when we talked about the first flight, we were looking at a graph. For this second flight, we're looking at an equation, okay? They're telling me that f of x is still the number of miles the helicopter is from its destination after x hours, okay? So let's kind of envision, what would that graph look like? So thinking back to slope-intercept form, we know that if 350 is b, and notice up here they told me they're traveling 50 miles further, then my new y-intercept for my second flight would be at 0 hours, I'm 350 miles from my destination. So this point right here that it's at 300 for my first flight would actually be up on 350. Okay, so I know when I start, I'm 350 miles away from my destination during my second flight. Then the next piece of information that they changed, so remember back on our first one, we found that the speed, the rate of change here on my graph and in that scenario was 100 miles per hour. Well, notice here I'm going 25 miles per hour faster, and look at my slope. Look at m in my equation. Now, my slope, or my rate of change, remember that's that change in y over change in x, is equal to 125 miles per hour. Okay? So it wants to know, well, which flight is going to take less time? And they want us to explain. So my first flight took 3 hours, right? We noticed in our graph that it took us 3 hours. Well, this time they didn't tell us how long it took. So we have to use the information that they have given us to figure out how long would this flight take. So we know that they have 350 miles that they need to travel. And they're traveling at a rate of 125 miles per hour. So if I take the total distance that I need to travel and I divide it by my speed, then that should give me the time that the flight would take. So if I take my 350 and I divide it by 125 miles per hour, I find out that this flight is only going to take 2.8 hours. So why? Why does it take less time? even though I'm traveling a little bit further, my rate is going faster. So that's why it's going to take just a little bit less time. My rate of change was faster on this second graph, even though it accounted for that extra, distance that we had to travel. Okay? All right, so over the last 2.5 weeks or so, we've done a lot of material. We've talked about functions. We've talked about linear versus nonlinear. And now we're getting into more specific information when it comes to linear functions. We're going to spend about 12 to 18 weeks on linear functions. So if you're struggling or any of this vocabulary is giving you trouble, please watch these videos. If they don't help, come in for tutoring. If that doesn't help, log on to your online textbook and look at some extra examples. But whatever you do, make sure that you're addressing any needs that you have if you're struggling with this content. Okay, I will see you guys in class. Have a fantastic night.